Good morning. We are going to go through chapter 11 and 12, the final two chapters, which are in the year. So here it is. Let me open it up to our list of formulas. Okay, really 11 and 12 are largely just this list of formulas. I'm going to go through and narrate it. So starting off with a rectangle, let's make this nice and big for people. Starting off with a rectangle, this is really bottom line the only formula that we actually need. The formula for a rectangle is base times height. Everything else is based on that, um, Anyway, a base and a height in all cases must be perpendicular to one another. There is no rule which says the base has to be the one on the bottom. The area of something doesn't change if you rotate it. So if all of a sudden something else is on the bottom, it doesn't change the area. And equally importantly, when we get onto volumes, it doesn't change anything either. A square is a case of a rectangle where the base and the height are the same things and they are the lengths of the sides. So I can just take the length of the side and square it. What is going on over here? This should be a parallelogram. I don't know what happened there. Let's just change it to p-gram and we'll do Control C, Control V. We'll delete that. It is base times height again. Now, what makes a parallelogram more tricky than a rectangle is in a rectangle, the base and the height are just the two sides. For a parallelogram, the base is going to be one side and the height is the corresponding height, which is perpendicular to whatever you defined as the base. Again, if you really understand a rectangle, you could always chop up a parallelogram and rearrange it so that it forms a rectangle. With two congruent triangles, I could split them up and form a rectangle which has the base and the height of the triangle. And since there's two of them which make up the rectangle, the area of a triangle is going to be half that of a rectangle or parallelogram with the same base and height. So it's just 1/2 base times height. Here is another one which could take the place of pretty much everything here, including a triangle, and that is a trapezoid has an area which is the average of the bases times height. For rectangles and parallelograms, the bases have the same length, so when I average two of them, I just end up with one of the bases and base times height. There's a second formula down here, which is median times height, which is to remind us that the median has a length which is equal to the average of the bases. We could do a nice little proof of that if we were interested. Kites, you'll notice I put an asterisk here because kites include all shapes which are also kites, such as rhombuses and squares. And the area of a kite is 1/2 diagonal 1 times diagonal 2. Equilateral triangle is this complicated formula, 1/4 s squared times the square root of 3. I usually say square root of 3 over 4 times s squared, or s squared over 4 root 3. All of those are acceptable. This looks like a good way of writing it out. A regular polygon is 1/2 apothem times perimeter. That apothem starts at the center of a polygon and is the perpendicular bisector of one of the sides, and P, of course, is the perimeter. A example of an extreme regular polygon is a circle. This formula would work for a circle as well, but the area is just pi r squared to be simple. I don't give the formula for the area of a sector. Instead, I write this proportion. The central angle is to 360 as the area of a sector is 2 pi r squared. And for a circle segment, I find the area of the whole sector and subtract the triangle. There were 3 theorems. Let's see if we can squeeze them onto the screen here. If two triangles have the same base, then the ratio of their heights is equal to the ratio of their areas. Or if they have the same height, then the ratio of the bases is the ratio of the areas. I don't know what this random 9 is doing floating around here. See if I can delete that. Delete. And if two figures are similar, then the ratio of their lengths squared is the ratio of their areas. And that one comes back to us a little bit in chapter 12. Chapter 12, the chapter we've done most recently, we looked at really 3 different shapes, but we took a special case of a special prism called a cylinder and a special pyramid called a cone. And I separated out those formulas, although they are unnecessary. And we looked at these 3 attributes, the lateral area, surface area, and volume. So a prism, once again, is defined as a, is made by a pair of congruent and parallel shapes, which are joined by rectangles. Now those shapes are the bases, and again, base does not mean bottom. The bases don't have to be on the bottom of these shapes. The lateral area of a prism is the area of all the sides which aren't the bases, so all those rectangles. It is the perimeter of the base, not perimeter of the bottom, but perimeter of the base, times the height. And again, height is not just the distance from the bottom to the top, it is the distance between the 2 bases. If the bases are on the sides, it's the distance from one side to the other side. The cylinder, it's the perimeter of the cylinder, which is 2 pi r. There was supposed to be an r instead of a 2 in there. Let's fix that real quick. 2 pi r times the height of the cylinder. Again, the distance between the 2 bases. For any sort of pyramid, it is 1/2 perimeter times slant height, which is not the height, but the height up the slant. And for a cone, that simplifies to pi times the radius times that slant height, not necessarily the height again. Doesn't make any sense to speak of a lateral area of a sphere. So let's move on to surface areas. For every prism, it is the lateral area, which are all the surfaces which aren't bases, plus the area of those 2 bases, because there are 2 of them. Same for a cylinder, it's the lateral area plus those 2 bases. Well, those bases are circles, so plus 2 of those pi r squared. For a pyramid, there's only 1 base, so when I add I only add 1 base. Likewise, a cone is a special pyramid, so I'm only adding that 1 base, which is a circle, so adding 1 of those pi r squareds. The area of a sphere is given by 4 pi r squared. And lastly, we get down to the volumes of these things. Volume of a prism is base times height. I know that you were taught length times width times height, which works fine for a rectangular prism because the area of the base is length times width. But for any other type of prism, that doesn't make any sense. For a cylinder, it's still base times height, but that base is a circle, so its area is pi r squared times that height. For any sort of pyramid, including cones, it's 1/3 base times height, and a cone, looks like we're missing something here as well, 1/3 base times height. The base is that pi r squared business. We can make this a little bit bigger so we can see that all now. And the volume of a sphere is given by the awkward formula 4/3 pi r cubed, which makes some sense once you get to calculus. Okay, there was one large theorem here, which kind of was 2 things encompassed. If 2 objects are similar, then the ratio of their lengths squared is the ratio of their areas. Another way of saying that is if 2 objects are similar, then the square root of the ratio of their areas is the ratio of their lengths. And the other part of it is the ratio of their lengths cubed would equal the ratio of their volumes, or of course, the cube root of the ratio of their volumes would equal the ratio of their lengths. That is everything. All right, guys, have a good one, and I will be checking in with you.